All right, so we're solving systems of equations by graphing. Graphing is the third way that we've learned. Substitution is first way, elimination, and now graphing. I just did this one, so I'm not going to do it again. Number 26 was just asked about, but again, we drew a line that connected these 2 points and wrote what it was in slope-intercept form. Who remembers what it was? We just wrote it down. What was it, Lizzie? Wait, I think you're thinking the blue airplane. I did, yes. So the blue airplane, you're right. I went out of order, didn't I? The blue airplane has an equation of y equals 2x. And we decided that if with that slope of 2, it's going to actually end up crossing the y-axis at the origin, 0, 0. And so we don't need to put anything after. And then real quick, and I'm not going to get into the explanation of it, but we knew that using the slope of up 1 over 3, that this was going to cross the y-axis of 14. So y equals, what we say it was, negative 1/3? Mm-hmm. X plus 14. Okay. We also have done a problem like this before. One of my favorite problems of the school year. Do you remember doing the popcorn bucket problem? That was back like before Christmas, when we were first learning to solve like graph equations back in chapter 4. The problem said you buy a large bucket of popcorn, you're trying to go to the movies. The cost of a large bag of popcorn is $10. The annual popcorn bucket is $25. And $5 to refill it. So we've decided that if you go to the movies, intersection right there is at 5. If you go to the movies 5 times in a year, then that's that break-even point. That's when it wouldn't matter either way, whether you're buying a large bag of popcorn every time for $10, or if you just bought the popcorn bucket, you'd be spending the same amount of money. But if you go to the movies less than 4 times, don't buy the popcorn bucket. But if you go to the movies more than 4 times, definitely buy the popcorn bucket. So the blue line represents the popcorn bucket line. That's why it's starting up there at 25. The red line has a steeper slope. It represents the large bag of popcorn. So how many of you guys would say that you go to the movies 6 or more times in a year? You need the popcorn bucket then, unless you don't like popcorn. So everybody else in here goes less than 6 times? I go to the movies more than you. Okay. I mean, I realize COVID kind of shut things down for a while, but there's like 8 movies coming out between now and Christmas that I want to see. Just went to go see Doctor Strange.
That movie was excellent.
Going again this Saturday with the rest of my family.
You also just watch it.
Thor's coming out. Yeah, a year later. Thor's coming out. The new Avatar movie I saw in previews looks good.
Like Christmas,
but that's still this year, right?
Oh,
I'm saying for the new Jurassic World. Yes, I heard. Yes, that one's coming out. So I go more than 6. So I benefit from the popcorn bucket. So
I've been 3 times already this year. I want to see Batman.
ooh, I never got to see one, but it's on HBO Max. I'm gonna watch it this weekend. It's been on there for a while. Okay. Well, then you wouldn't want popcorn bucket. No, you can not saying you can't get popcorn. You just wouldn't want to spend the extra money on the bucket. Because okay. That would be a reason. If you buy the popcorn bucket,
I just get the kids
you'll go back
popcorn
more.
because it's cheaper and it can be the drink.
All right, here are your rules for solving by graphing. Write both equations in slope-intercept form. That's important because you have to be able to graph them. Graph the lines, find the point of intersection, and then write that as an ordered pair. So on your homework tonight, you do not have to draw any graphs. What most of your homework is going to be is 2 things. For number one, you'll be writing down the answer. So when you have problems like this on your homework, since Big Ideas already has the graph for you, you'll just write down your answer as an ordered pair. Eventually, you'll get to problems where they aren't giving you the equations in slope-intercept form, and you'll have some work to get them into slope-intercept form. We'll see those in just a minute. So for this one, we'll do the top line in red. And so it has a y-intercept of 5 and a slope of 2. So there's my y-intercept. What's 2 as a fraction, Emerson? Perfect. So I can rise 2, run 1, or I can even go down 2 and left 1. Remember, going down 2 and left are both negative directions, and 2 negatives make a positive. So there's my first line. And Notability is going to make this super nice. In fact, Monday's worksheet that you're going to get is the graphing worksheet, and I'm not doing paper copies. We're doing it on Notability because of this reason. And then the second line I'll do in a different color. We'll say purple, just because there's already blue lines on this graph. And that one has a slope of -4 and a y-intercept of -1. So I graph the y-intercept first. See, this is a good review of graphing, right? This is a good review of that before you guys graduate to 8th grade and they assume you remember all this stuff. So then we're going to go down 4 over 1 for the same reason Emerson said, we just put it over 1, down 4 over 1. Make sure you're going 1 to the right though. Because if you go down 4 and left 1, that's negative and negative, actually a positive. You could go up 4 and then you could go left 1 that way. And right there, that kind of tells you what the intersection is. But that was not a very good line. Let's try that again. And what is that intersection point, Chloe? -1, 3, and we have our answer. Of all the ways to solve a system of equations, the graphing one probably takes the least amount of work if they're in slope-intercept form. If I wasn't graphing and I was solving using substitution or elimination, substitution would work here because I could just plug the 2x plus 5 from the top equation in right there. Watch what happens when I do that, by the way. You don't need to write this down, just watch what happens. If I plug the 2x, if I substitute, I should stop saying plug in. If I substitute the 2x plus 5 into that y, it'll look like that. I'll move the -4x's to the left side by adding 4x. That'll make it 6x. And I'll move the 5's over to the opposite side by subtracting 5. That'll make it -6. And that's going to give me x equals -1. And guess what x was equal to? -1. And then I plug that x equals -1 back into either of the equations and I'll get y equals 3. So all 3 methods end up giving you the same answer. I will say that if you don't have graph paper and you're sketching the graph on your own, graphing can be the least accurate, especially if you're not a very good straight line person. You can't draw a straight line to save your life. Then substitution elimination, at least you're just working with numbers. But if you have graph paper and on big ideas, you obviously have a computer graphing the line for you, it would be easy to do. On the other one, we've got, we'll do the top line in purple, y equals -x plus 3. Oliver, what's our y-intercept there on that top equation? It is 3, okay. So we'll put a point right there. And then -x. Jimmy, what's the slope of that? -x. That's right, -1 over 1. Down 1, over 1 to the right, or you could go up 1 and over 1 to the left. And so that's going to give us a line at a 45-degree angle. Big Ideas likes 45-degree angles. Your line might even snap into that position. I did not draw a very good one. And then for the bottom equation, I'll do this one in green. Y equals -1. Maddox, what's the y-intercept? It is -1, yeah. Yep, it's -1. And the reason it probably did is because you're looking for that intercept to be at the end. There was no slope, right? There's no x value. The m value in front of the x value isn't there. What must the m have been to make the x value vanish? Xander? 0. A 0. And can you tell me what a 0 slope looks like? Horizontal. This will be a horizontal line. That's why that says y equals 1, because y equals 1 everywhere on that line. And the intersection point, I didn't do a very good job of graphing the purple line. It should be right there. Carter, what is that intersection point?
That is that'd be -1.
Give me the whole point.
Oh, it'd be 4 -1.
4 -1. Got it. 4 -1. Okay. Moving on. That's pretty much what this homework is. We'll do the top one in pink. Or I'll do it in pink. You can do whatever color you want to do it in. Hello? Yes. Okay, I'll sit him down. Hi. Martin, no, you are getting picked up. Homework's on big ideas, so you're not missing anything. I don't need to worry anything. Alex, what is the y-intercept? It's 0. Yeah, there isn't a b value here. That means it is crossing at the origin. Doesn't mean it doesn't exist. It just means it's 0. And then the slope, what's the m value, Alex? That's right. So we're going that way. And we're going that way. Again, at a 45-degree angle. And then for the second equation, do this one in dark blue, navy blue. Lucy, what's the y-intercept? That's right, +3. And the slope? 1/4. Rise 1, run 4, go down 1, left 4. And you can see that intersection point. Brady Schnurple, what is that intersection point right there? 4, 4. Remember, you can always double check your answer by plugging in to see if 4 for X and 4 for Y works in the top equation and also in the bottom. I tell you, it works right now. It works in the top equation. If it works in the bottom equation, we have it right. If I plug in X for 4 for X, 1/4 of 4 is 1, add 3 to that, and you'll get 4, and that's what I plug in for Y, and it works. So you can always double check, even if you don't have a big ideas check answer button. Alex, question? I'll call on someone else. We'll let Garrett do the example D. We'll do that top equation in red. Garrett, what's the y-intercept? And what's the slope? -1/1. So we're going to go down 1 and 1 to the right. We could also go up 1 and 1 to the left. You should be able to tell. There we go. I didn't do very good at graphing a point here because it's wanting to snap into a different spot. You should be able to tell if it's a negative slope, if it's going downhill from left to right, as this one is. Otherwise, you would have it wrong. And then for the second line, we'll do that one in green. And Sky, give this one a shot. What's the y-intercept? And the slope is, okay, so I'm going to rise how many, Sky? Over, that's right. Perfect. I could also go the other way, just trying to make sure my line's straight as possible. Sky, what is our intersection point for this one? Oh, I set her up. I set her up good. One disadvantage to graphing a linear system is that it's not always easy to find the exact intersection. The last several problems, they've been intersecting these nice integer values, but you know that like other numbers exist, right? And so on the number line, it's possible that lines would cross somewhere in this territory. That is a disadvantage with graphing because I'm not exactly sure, even with using a nice piece of grid paper here, what that is. That's where substitution and elimination kick in. Because substitution, I'll be able to get an exact answer. And so why don't we try substituting? Let me look ahead to see if that's what we have. Yeah, that's exactly what we're going to do right here. We're going to substitute the -x minus 5 and for that y right there, making this new equation on bottom, -x minus 5 equals 3x plus 1. Move your x's to the same side. Probably easier to keep them positive. And add x to both sides to make it 4x on the right side. And if I move my x's to the right side, my constants have to move to the left side.
Well, that was weird.
So I'm going to subtract.
Go beat him up, Mr. Bright.
Oh, okay. If anyone's allowed to beat on a locker or a water fountain, in that case, it would be the custodian. Because that's how we get things to work.
You're gonna go beat him up. I
So-
saw it in your eyes.
I was just gonna go yell, that's all. So we're not sharing water, I hope. I have two football players that both got quarantined during the football season. Sharing water? Didn't you guys both get at one point? You never did? So that's why you're sharing the water. Well, yeah, well, we don't, that's a bad habit to get into. You shouldn't share water. You shouldn't share forks and spoons and, I mean, germs, guys, come on. Especially after we just survived a pandemic. Subtract 1 from both sides. That's going to give you -6 on this side. And then divide by 4. You'll get -6/4, which is the same as, Carson? I said -6 divided by 4. -1/2. Yeah, -1/2 or -1.5. So if the x value is -1.5, I can plug that in for like maybe that spot right there. If I plug in -1.5 to a -x, that will make it +1.5. And if I subtract 5 from that, that's going to give me -3.5, unless my math is off. And let's see if that looks about right. X is -1.5. That looks good. Y is -3.5. Yeah. So if they don't intersect at nice spots, graphing is probably not the best way to go about it. That's okay. We have other ways to be able to get exact answers. So now what we're going to do is I'm going to give you some problems that aren't already in slope-intercept form. At least one of the equations might not be. In example F, neither of them are. So we're going to have to turn them into. This is where your work paper comes in. A lot of your work paper might just have answers. And then you'll get to problems like this where you'll have to convert them to slope-intercept form. Y equals -4x minus 7 is already in slope-intercept form. I need a volunteer that would help me convert x plus y equals 2 into slope-intercept form. Anyone at all? Anyone at all? Thank you, Julia. Finally. All right. Julia, what would x plus y equals 2 be in slope-intercept form? That's right. Move that x over to the other side. And now I can graph both of them. We'll graph that one that we just did in red because I've got it written in red. The slope is, the y-intercept is 2 and the slope is -1. So we're going to go down 1 over 1. So there's the first line. And then for the top equation, we'll just do this one in dark blue. The y-intercept is -7 and the slope is -4. So the y-intercept is -7. That's at the very bottom of my graph here, although the number lines do go on forever. And then my slope is -4. Oh, what do I do if I can't go down 4 over 1? Maddox? Go the other direction. If you can't, yeah, right. If you can't go down and to the right, go up 4 and to the left 1. And that's the same negative slope. And let's see if we can tell where they're going to cross. I don't think that's a very good line. You could always go back through and like up 4 again and over 1. Up 1, 2, 3, 4 over 1. Okay, so you could keep using that slope to guide your line because even though Notability will make a straight line, I might not make it go in the right direction. So we do have this nice intersection for this one, and it's right there. Garrett, what is that point right there? -3, 5 is my answer. Nice. -3, 5. And Jacoby, what are those things that go around the numbers? Parentheses. Good job. All right, next one. X minus y equals 5 and -6x plus 2y equals -2. Maddox, which one do you want to do? Top one, convert it to slope intercept form for me. We'll do it in this weird orange color here.
Okay, so. Check both sides.
y with all the sides of the other side, so it would be y equals x minus 5.
Okay, so by moving the x over to the other side, it doesn't get rid of the minus sign that's with the y. That minus sign's a negative sign, so we don't want negative y. So Maddox is saying times everything by -1 to make it y equals positive x minus 5. Okay, awesome. So we have one equation done, y equals positive x minus 5. Y-intercept is -5. The slope is 1. Pretty common number for these examples is the slope being 1 or -1 the whole time. Okay, now for the bottom equation, we'll do that one in this nice little teal color. Carson. You could do, I guess you could do that first. I was thinking we're probably wanting to move it over to the other side first, just in case it's not divisible by 2. So that way you get, when you get your fraction, you have to move the fraction over. No. Now you move the 6x over the other side, it becomes positive 6x. I agree with that. What you forgot to do was divide the 6x by 2. So that's going to give us 2y equals 6x minus 2. When you divide everything by 2, what do you get, Carson? There you go. Got it. I think you had the y and you had the -1. We just needed the 3x there. Okay, so then we're going to go down to -1 on the y-axis. We're going to have a slope of 3, rise 3, run 1. They're not meeting in that direction. Go down 3 over 1, go down 3 over 1. And right there at the bottom of our graph, those points are going to intersect. Okay. And Jace, what is this point down here? That's right. -2, -7. Doesn't show up very well. Let's try to make that darker. There we go. And a story problem. A kicker on the football team scores 1 point for making an extra point and 3 points for making a field goal. The kicker makes a total of 8 extra points and field goals in a game and scored 12 points.
That man is on fire.
Write and solve a system of linear equations to find the number x of extra points and the number y of field goals. So there's 2 equations we should be able to derive from that paragraph right there. Who can give me one of them? Lizzie. That's right. I'm going to use x and y in place of e and f, okay? Not that that matters a whole lot, but just so we're using the same variables here. So x stood for extra points. She says that x plus y is equal to 8. And she gets that from the fact that there was 8 extra points and field goals made in that game. So if you total them up, there was 8 kicks that win it, okay? So there's our first equation, total number of kicks equation. Now we need a total number of points equation. Xander, you want to give that one a shot?
8 plus y equals 12.
Say that again.
8 plus y equals 12.
Not 8 plus y equals 12. You're assuming there was 8 extra points. It said there was 8 extra points and field goals total. So think about how many points each of them is worth. Dawson, you can give it a shot? That's right. Nice job. So an extra point is worth 1 point. So 1x, or x, plus 3y, because each field goal is worth 3 points, equals a total of 12. Exactly. And if I was using substitution or elimination here, both of them would be pretty quick. You could eliminate the x's very easily. You could also move the y on the top side over the other side. You could plug in, but we're graphing today. So we need to turn both these into slope-intercept form. So sometimes graphing is not the fastest way, just like sometimes substitution is not the fastest way, and sometimes elimination is not the fastest way. So let's do the top equation again. Connor, what's that top equation in slope-intercept form? That's right. So we go to 8 on the y-axis. And then we go to negative, our slope is -1, because that's our m value, because the negative x there. So we're going to go down 1 over 1. In fact, actually, I don't even need an arrow on this one. It would just be a segment. That's because I can't have a negative number of kicks and I can't have a negative number of points. So there's no need to have any other quadrant than quadrant 1 right here. So if you just told me that I had 8 kicks, that's the line I would draw. And that means I could have had 8 extra points and no field goals, 7 extra points and 1 field goal, 6 extra points and 2 field goals, all the way down to 8 field goals with no extra points. That would give me 8 kicks. But they gave us more information than that. They told us how many points we scored. So I don't need to guess how many kicks there is. I'm going to find out for sure once I graph this total points line. Okay. And so for the total points line, Lizzie, go ahead and turn it into slope-intercept form. Start with 3y. Not x plus 12. Not x minus 12. 12. Can I put negative x plus 12? Okay. All right. And then what? Good. So y equals good. Plus 4. Excellent. Do you remember back at the very beginning of the year, we were doing problems like this? It seems like forever ago. And I had a lot of people doing this. And I'd count that wrong. I'd say, no, you can't write it like that. And you'd argue with me. You see now why you can't write it that way? That doesn't tell me what my slope and what y-intercept is. I actually have to divide both of those individual numbers by 3. And so she's exactly right. We're going to get y equals negative 1/3 plus 4. Oh, there's an x there. She said that. I didn't write it. There we go. So we go up to 4 on the y-axis. We're going to go down 1 over 3. That didn't intersect. But if we go down 1 over 3 again, it will. And then we have our intersection point being, remember, x was the field goals. So the x-axis is the field goals. No, that's not right. X was the extra points. Sorry, misread that. So these were the extra points, and this axis was the field goals axis. And so when those points intersect right there, the x value being 6 means 6 extra points and 2 field goals. That will give me 12 points. 6 extra points is 6 points. 2 field goals is also 6 points. That gives me 12. That's the only way I can score 12 points, by making 8 kicks. You could say, well, what if you just kicked 4 field goals? Wouldn't that be 12 points? It would, but then you only make 4 kicks. And so there's only one spot where both these lines intersect. And everything in this story problem is true. All right, the break-even point. The break-even point of a company is when the cost equals the revenue. Now, if you don't know what cost and revenue are, if you own a company, the cost is all the expenses you have. You have to pay for the lease on the building. You have to pay for the electric in the building. You have to pay your employees healthcare insurance. You have to pay their salaries. You have to buy the product so you can sell it, right? I mean, some companies like Walmart make their own product. Meijer makes their own product and they sell some of their own stuff, but they also sell other suppliers as well. So you have to buy all that and then sell it. All of that is your cost, and it can be really expensive. The revenue is all the money you take in. Okay, so think of a lemonade stand. What would you need to buy for a lemonade stand? Assuming you already had the stand.
Water, lemonade, mix,
Lemonade mix, water,
possibly ice, possibly.
ice cups. Okay, so after you go out and buy all that stuff, that's your cost. The revenue is how much you're going to sell it for and how much you bring it in for. You get to set the price, right? Now, if you set the price too high, no one's going to buy a $10 cup of lemonade. No one's going to do it, right? Maybe grandma comes by and says hi, says, I'll give you $10 and you can keep the cup of lemonade, right? But no one's going to buy that. So you have to set the right price. But all the money that comes in is called the revenue. And then you use that revenue to pay off your costs. Whatever's left over is called profit. Okay, you want your profit to be positive. In this problem, it's breaking even. That means your profit is zero. Is it good to have a profit of zero?
No.
Can your company survive if your cost equals its revenue?
No.
No, you won't be able to make any money. I mean, I guess your employees don't care as long as they're getting paid, but you wouldn't make any money as the owner. So you want your profit to be positive. So we're trying to find where the break-even point is. In this first problem, it says your family starts a bed and breakfast. It spends $500 to fix up the bedroom. The cost of food and utilities is $10 per night. The family charges $60 per night to rent the bedroom. Find the break-even point. So let's write an equation for that. We'll call it our cost equation. What are all of our costs? Shane? Fixing up the bedroom. That's a one-time $500 cost, right? Would that be our slope or our y-intercept? That's right. That's our y-intercept. It's our initial value. $500. And what else are we having to pay for? The food and utilities. That's right. So 10x plus 500. And if I graph that, 500 is all the way up here. I can't go up 10 because what are we counting by? 50s. But going up 10 over 1 is the same as going up 50 over 5. Up 50 over 5 is the same as 10 over 1. It's the same slope. So there is my cost equation. My revenue equation is what? How much money am I bringing in per night? Xander?
$60.
$60 per night. What's my y-intercept, Xander?
0.
0. So it starts at 0. Yeah. Some companies, they don't really make a profit until the first couple of years. So I start at 0, but my slope is 60. Now I also can't rise 60 over 1. But instead of rising 60 over 1, that's the same as rising 300 over what? 5. Okay. So rise 300 over 5. Let's finish this problem before you leave. Rise another 300. That's up to 600 over 5. Puts me there. That point that my lines meet at is called my break-even point, where my cost equals my revenue. So it won't be until the 11th night that I actually turn a profit. But the 11th night's not my answer. The break-even point is my 10th night. So after 10 nights, that's my X value. And how many dollars was that? What's my Y value right there? 600. 10 nights, $600. That's my break even. We'll look at number 4 and you come back Monday. If you need more help, cost revenue, we got another example we'll look at. Have a great day. All right, number 4, let C represent the cost and R represent the revenue. We talked on Friday about how cost is all the money, all your expenses you have to pay. Revenue is all the money you bring in. And if you spend more than you bring in, that's a negative profit. You're not going to last very long. If you make more than you bring in, that's a positive profit. And if you make the same amount that you spend, that's a profit of 0, which is still bad, but that's the break-even point we're referring to here. So the break-even point is when profit equals 0. When is profit going to equal 0? When cost equals revenue. There'll be no profit. So if I want my cost to equal my revenue, I'm just going to simply set them equal to each other. Now, I know this isn't a graphing homework, but they didn't give you a graph for number 4. So we're just going to use substitution. If C equals R, that means 15x plus 150 equals 45x. Martin, move the 15x over to the other side. Good job. Okay. Christian, divide by 30. Five, okay. So 5 is my x value. And then once I know x is 5, I can plug it into either equation. It's probably going to be easier to plug it into the bottom equation. What's 45 times 5? This is for anyone. Deegan? 225? Getting some head nods on that? So there's my answer. In our last problem, we had labels for the x and y. X was nights, y was dollars. And so we actually got to see when it was going to break even. Or better yet, it's funny, I was actually going to the movie theater this weekend. So I went to go see Doctor Strange again. This time I went with my family. And I showed them the problem that I do with my the AMC popcorn bucket, because that's where we go. And they called me a nerd. They're like, do you always give your students like problems so that you can figure out how much money you're going to save? I'm like, no, I'm trying to help them figure out how much money they would save. I already know how much money I'm going to save. As long as I go to the movies more than 5 times, because my break-even point's 5 here, right? If I go to the movies more than 5 times in a year, the popcorn bucket will save me money. If I go to the movies less times than 5 or less times, then the popcorn bucket isn't worth it. Okay, that's it. Just trying to help you take advantage of your resources.